Okay, welcome back. And today we're going to talk about measurements of center or central tendency, measures of central tendency. And so today, the things that we're going to talk about mainly are these things. We're going to talk, so let me put it up here, measures of central tendency. And so those are going to be things like the mean, median, mode, and what we're going to call the mid-range. Okay, so I'm going to briefly talk about a lot of these, or all four of these, but we're going to mainly talk mostly about these three. Okay, this one is not used very often at all. Okay, so but we'll talk about these four, and we're going to talk how they're related, but they're all measures of center. So as we discuss this, or as we go through this, just realize that the first thing, we're going to talk about the basics, and the first thing when it comes to statistics is whenever I get a new data set or a data set that I'm unfamiliar with, and I want to learn more about the data, the very first thing is I want to know where the center of the data is, and I want to know how spread out the data is. Okay? So that's like the first thing that anyone will do when you're analyzing data that you're not familiar with is, hey, where's the center and how spread out is the data around the center? Okay? And so that's what we're going to talk about in this section, in this video, and in the next video for the next section. Okay? So measures of central tendency is what we're going to talk about today. So the first thing we're going to talk about is the average or the mean. Okay? So we're going to talk about very briefly the population mean and the sample mean. The sample mean is the one we're going to use most often in this class. Okay? So the mean, or the arithmetic average, is what we use all the time. We're very familiar with the average. We've been doing this since grade school. You know, give a set of numbers, find the average. Okay, that is a measurement of center. Okay, so let's see. So the mean, or what we call the arithmetic average, or just average for short, okay, is very simple. It's a very simple calculation. You're going to want to know this formula, but for the population mean, again, the population mean is mu, and the way we calculate the population mean mu is we take the sum, and so that's the Greek letter for sigma, the capital letter sigma, which means the summation. It's a summation sign, which means that we're going to sum all of the values in the population. So whatever those values are, we're going to call every one of those values x. Okay, we talked about that before. So we're going to sum all of the values in the population, and then we're going to divide by the size of the population. Okay, and we denote that by a capital N. Okay, so this is the formula for mu. Okay, now most of the time we don't know what mu is because we don't know what the population is. But in the case that we were able to know the population, we could calculate the parameter mu, the population mean. Now, for the sample mean, it's the exact same calculation except for one change. So if we wanted to calculate the sample mean, x bar, that function, or that formula rather, is the summation of all of the values of x in the sample, which is small n, lowercase n. Okay? So this is the population mean formula. And this is the sample mean formula. Okay? So know them both. Okay? Now, let's talk about the median. Okay, so how do we calculate the median? The median is another measurement of center. Okay, now the median finds the exact middle point of the data set, the exact middle, the middle point. Okay, where 50% fall below that number, 50% of the data falls above that number. That's the median. Okay, so how do we calculate the median? Well, there's a two-step process to figuring this out, and there's two cases to consider. Okay, the first step is we need to order the data. Okay, so we can either order either greatest to least or least to greatest. Okay, however you want to organize it and order it is fine. Okay, so this median involves a two-step process. Okay, so the median or the 50%. How do we want to do this? I would say the exact middle. So in other words, 50% of the data is below and 50% of the data is above. Okay, so now, okay, step one. Order the data. Okay? Least to greatest or greatest to least, that's fine. Okay? So step one is you order the data. Once you have the data ordered, then it becomes easy. Now I'm going to basically show you two ways of doing it. If you have a small data set, then it's very easy. You just start with the end numbers and you just count visually until you get the middle. Okay? So you're going to have two cases. Either the middle is going to exist or there will not be a middle. Okay? So that has to deal with the parity of the data set, which is either odd or even. Do you have an odd number of values or do you have an even number of values in your data set? Okay? So step two involves either case one, your data set is odd. In case two, your data set is even. Okay? Now, if your data set is odd, then again, either we can, if it's odd, then we know that there's a middle, right? Because if you think about it, if it's an odd number of data sets, we can pair up observations and there's going to be one left out, okay? So if you order your data set and you have a small data set, you could do this easily, you just count out till you get to the middle number, and whatever the middle number is, that's your median. Okay, that's simple. Okay? If it's an even data set, and it's a small data set that you can use, then visually you do the same thing. You pair it up from least to greatest, and you work your way in till you get to the middle, but there's no middle number, so what you do is you take the two middle numbers, and you take the average of the two middle numbers. So that's really by inspection how you can do it. Okay, that's easy if you have a small data set, like 5, 10 numbers. You can easily order them and just visually count to the middle. Okay, so that's kind of easy if you think about it. Okay, it's intuitive. So whatever the middle is, if it's an odd number, then you know that there's a middle number. You just have to find it. Okay, If it's an even number, then you know that there's no middle number, so you just have to find the middle two, and then you take the average of the two middle numbers. Okay, that's really all it is. Now, if you have a large data set, like 30, 40 numbers, then you're not going to want to try to order this and then visually go through. Okay, so I'm going to show you the two formulas that you're going to use to find the position in order to find the middle term. So the formula that you can use, if it's an odd case, we're going to use the letter I. Letter I is the position where the median is located. Okay? If it's an odd number, and again, this is under the assumption that you've already ordered the data. So what we're basically saying is, how many positions do I need to count from one end of my data set to find the median? Okay, that's what I is going to tell you. How many numbers do I need to count from one end of my data set, given that it's ordered, to get to the median? Okay, so if it's an odd number of values in my data set, the formula that I'm going to use is going to be n plus 1 divided by 2. So n, remember what n represents. N is the sample size. Okay? So if my sample size is 13, then I'm going to use this formula because it's odd. So in that case, if I put in 13 plus 1 divided by 2, then I'm going to get 7. Now, just for clarification, this is not telling me that 7 is the median. This is just telling me how many spots I need to count from either end of my data set to get to the median. Okay, I'm going to show you that in an example in a moment. Okay? Now, if it's an even case, then I know I have to find the two middle terms and average them. So I'm going to show you the formula for finding the first one, and then once you found the first one, then you just have to take the next one, and those are the two numbers you're going to average. Okay? And again, the formula that I'm going to tell you is just the formula for finding the position of where the first number was located. Okay? So in the even case, it's very easy. E is just going to be, I is just going to be n divided by 2. And then all you have to do is to find the next one. It's just going to be n divided by 2. Well, no, that's not necessarily. Oh yeah, n divided by 2 minus 1. Okay? So it's going to be the next position, right? So like I said, that should make sense, because what I just said was, you find the first one, right? So this is going to give you the position of the first one, and then you just take the next one, which is just going to be n divided by 2 plus 1. Okay? So, hold on a second. Okay, so, 1, 2. Okay, so anyway, so this is so basically once you find the position, so let's take the example that, let's say it's 16. Let's say my data set was 16, the size 16. So if I put 16 into here, then the position that I'm looking for is the 8th position. Again, this is not telling me my median is 8, it's telling me how many spots that I need to count to find the median, the first one, the first number that I need the average. And again, I'm going to show you an example, but again, just remember these two formulas. You're going to use this formula here for odd cases. You're going to use this formula here for even cases. And again, I'm going to show you an example in a moment of how to find the median of the data set. Okay? Okay. So now, the mode. Let's talk about the mode. This is a really easy concept. The mode is just the most frequent value that comes up in the data set. That's all it is. So if you have a data set and you look at the numbers, whatever value happens the most frequently in the data set, that's going to be your mode. So mode is very easy to understand. It's the most frequent value, or values if there's more than one. Okay, so if there's only one value that occurs the most, then we would say that that's unimodal. Okay? If there's two values that happen the most with the same amount of frequency, then we would say that that would be bimodal. And then if there's three or more, then what we would do is we would call that multimodal. Okay, so that's really the idea. That's the definition of mode. Okay, so very simple, very straightforward. Okay, and again, we're going to talk about this in a minute when we see an example. And midrange, the last thing. Now again, I'm not going to spend a lot of time on midrange, but the midrange, it's a very crude measurement. It's very quick, it's very easy to do. It'll give you a quick idea of where the center is, but again, it's very sensitive to outliers, which we'll talk about later on. But it's not very useful as far as any kind of really deep analytics. But if I wanted to do a gut check and I wanted to do some quick, the mid-range would be a very easy calculation, okay? So the mid-range, which is denoted MR, is you just take the maximum value plus the minimum value and divide by 2. So you're basically finding the midpoint between the maximum and minimum value to find where the center is, okay? Well, the one thing is it only relies on 2 of the data points, okay? So if I have a sample size of 100 values, I'm only using 2 of those values to find the center, okay? So again, it doesn't use all the data. Whereas if you use the average, now the good thing about the average is that the mean uses all of the data, okay? The median, again, median doesn't use all of the data directly, okay, to find the median. It uses a part of it. So again, keep that in mind, okay? There are going to be good situations, depending on what situation we're dealing with, the mean, the median, the mode may be better than other measurements, okay? So again, this is the mid-range. The mid-range isn't used very often. We're not going to really probably cover a lot of this. So again, I just wanted to show you, it's a very crude. If somebody gave me a data set and I wanted a quick calculation of where the center would be, I could do this very quickly and have an idea. Again, if I have really big values or really small values, then it could affect, it will affect the mid-range significantly, okay? Okay, so that's the 4 things I want to talk about. So now let's do an example and I'll show you how to calculate for each example using the formulas, okay? So, let's use this example here. So now this is the number of months. So this data, that I'm going to write down, represents the number of months that someone with AIDS survives or lives for after they're given a new antibody drug. Okay, so this is a new antibody drug, and after they're given this, taking this new antibody drug, this is the number of months. So this data represents the number of months that these individuals lived. So these are all my X values. Okay, so I think I have all the data on account. So 40 numbers. So I should have 40 numbers on here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, so I have 40 numbers on it. Okay, so I have all 40 numbers. So of these 40 numbers, I'm going to calculate the mean. Okay, so let's start by calculating the mean. So using the formula, I'm going to calculate the mean x bar, so the sample mean. So the sample mean, this formula is the sum of all x divided by the sample size n. Well, what's n? Well, n is 40 in this case, okay? So I'm going to sum up all of these values, that's what this means, and I'm going to divide by 40. Okay, so now you can do this on the calculator, that's what I would do. So if you sum up all these on the calculator, and that's what I'm going to do right now. So it's just a quick calculation, okay? So I would follow along and do it with me. So I get 943. So what I end up is 943 divided by 40. And so if I divide by 40, I get an average of 23. Okay, now remember the rounding rules. Okay, so I'm doing a calculation, I'm calculating the mean. What were the rounding rules? Well, my original data is in whole numbers. So any calculations I do, one, I don't want to round off until the very end, which is what I did. Okay, so I got my final answer here, and I want my answer to go out one more decimal than the original data. So I want to go out to 1 decimal place. So if I round to 1 decimal place, I get 23.6 because my number is 23.575. So that rounds to 23.6 months. Okay, so the average number of months that an individual lives after taking this new medication, this new antibody drug, is almost 2 years. Okay, so that's the average. Okay, so now, what about the median? So let's talk about the median. Okay, now, in this case, what do I have? Do I have an even number of observations or an odd number of observations? Well, n is 40, so the sample size is 40, so that means I have an even number, which means there's no middle, right? Which means that to find the median, I need to find the 2 middle numbers and average them. Well, remember, what's the first step in finding the median? The data has to be ordered from least to greatest or greatest to least. Now, the good thing about this data set in this example is that it's already ordered for you. But keep in mind that it may not always be ordered for you, so the very first thing to do is order the data. And I can't tell you how many times I get students that will forget that, and they'll just take the data set as is, unordered, and just start counting, or they'll use the formula that I'm going to show you, and then they just count without ordering the data. So remember, step number 1 to finding the median is to order the data. So always order the data. Okay, so let's find the median, and we abbreviate median as MED. Okay, so now, this is an even data set, like we said. Okay, so now, I'm going to use the formula to find the position of the first number. So what am I going to do? I'm going to use I equals, since it's even, I'm going to use n divided by 2. That's going to give me the first position. Okay, so n is 40. 40 divided by 2 is 20. So I'm going to count to the 20th position. And it doesn't matter if I start at this end or if I start at this end. I'm going to count out 20, and that's going to give me the first number I need. And then all I have to do is just take the next one. Okay? So let's count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now, I'm going to take this one and the next one. So those are my 2 numbers. Well, the cool thing about this is that they're both the same. So if I take the average of 24 and 24, it's going to be 24. So what's my median? 24. Okay? So in this case here, the median is going to equal 24. So now, notice that the median and the mean are very close to each other. We'll talk about that in a moment. Okay? Now the last thing is let's talk about mode. So mode is the most frequent observation. So all we have to do is look and see which number or numbers happens the most frequent. Now there's a lot of doubles. So let's see if there's one that happens 3. Okay, so is there any number that happens 3 times? And there's not. So we could look at this as multimodal, because there are a lot of values that happen twice, okay? And this might not be a good example of a mode, because we've got 2 here. Oh, let me do this in another color. So we've got 2 there. Yeah. 2 here, 2 here, 2 here, 2 here, obviously 2 here, 2 here, 2 here, 2 here, and 2 here, 2 here, and 2 there. Okay, so lots of things. In fact, this is a bad example to show mode. Because you've got a lot of different modes. This would almost be like a uniform distribution, to be honest with you, because you've got a lot of 1s and 2s. So in this case here, I would say it's really not any modes. But let's say there was one that happened 3 times. Then that would be the mode. Or let's say there was one that happened 4 times. That would be the mode. So just keep that in mind, is that the mode is the most frequent value that happens in the data set. Unfortunately, this is not a very good data set to use. Okay? What else? And the mid-range. Let's do the mid-range. I'll put a question mark here. So for mid-range, so let me erase this. Okay, so now the mid-range. So remember, the mid-range is just the max plus the minimum divided by 2. Okay, so the maximum value is 47 minus the minimum value, which is 3. And so we divide by 2. So what's the difference? It's going to be 44 divided by 2, or 22. So that's the mid-range, okay? So now, I've just shown you how to calculate the 4 different, or to find, calculate or find the 4 different measurements for center, okay? So let's talk about a couple of things. Notice how the mean and the median were just about the same. Okay, that's going to tell us something about the data set in a moment. Okay, but I'm going to shelve that to set that aside for a second. So now I've just showed you how to calculate the different measures of center for data given a data set. Well, what if you don't have a data set? What if you're just given a distribution set, a frequency distribution, right? So a frequency distribution, you don't have the data. All you have is a table of values, right? With frequencies. How do you handle those? Well, there's 2 cases, right? So there's the grouped frequency distribution and the ungrouped and the grouped frequency distribution. So let's do the grouped frequency, because what it's going to turn out is we're going to end up using the exact same formula. Okay? So if I have an ungrouped frequency distribution, so let's use this as an example. So now we're going to do calculating the mean. Oops. Of a frequency distribution. Okay. So we're going to do ungrouped first. So an ungrouped frequency distribution, you're going to use the exact same formula. You're going to use x bar is equal to sigma of x divided by n. Okay, and I'll show you how that works. Okay? So let's use an example to illustrate. Okay, well, think about it this way. Here's the formula in general. Okay, so we know we have 5 values, right, the frequency. So we have 5 values that are 0. 15 values are 1, 6 are 2, 3 observations have 3, and 1 observation is 4. Okay? So we actually have all of the data. I could write out all of the data just like this, like we had before, and I just can apply this formula the way it is. Okay? But here is the general formula for using for distributions. Okay? So I'm going to change this a little bit, but realize for ungrouped frequency distributions, you can use this formula if you interpret the table correctly. Okay? But the general formula is the sum of x times the frequency divided by the sum of all the frequencies. Okay, so do you see the connection? What are the sum of the frequencies? Well, that's the sum of this column. What should the sum of this column be? Well, it's going to be the sample size. So what's the sample size in this case? Well, it's going to be 30. Okay, so if I sum the frequencies, that's going to give me 30, which is the same as the sample size, n. Remember from previous conversations, previous videos? So that's one thing. So this is the same as this. So remember, if I take x, so x is 0, and I multiply it by the frequency, I get 0, right? Because 0 plus 0 plus 0 plus 0 plus 0, right? I add 0 5 times, I still get 0, right? If I'm going to take 1 times 15, well, how many ones do I have? I have 15 of them. 15 of the observations are 1. If I add those up, I'm going to get 15. So that's the same as taking the value times the number of times it comes up, right? Just multiplication. Repeated addition, right? So again, it's the same formula in the ungrouped case, okay? So in this example here, I'm going to multiply across. So here's what I'm going to do. I'm going to extend the table. So I'm going to take my next column and I'm going to find all of the products of x minus f. Okay? So 0 times 5 is 0. 1 times 15 is 15. 2 times 6 is 12. 3 times 3 is 9. And 4 times 1 is 4. Okay? So now what I'm going to do is I'm going to sum up these columns, because what am I doing? I'm taking all the products, here they are, here's the products, and I'm summing them up. That's what sigma means, I'm summing them up. So in other words, I'm summing this column. Okay? So, let me rewrite this so I have room. So here is the sum of the frequencies. And this is going to equal 30. this is going to be the sum of x times f, which is going to equal what? Well, this is going to be 20, 31, 40. It's going to be 40. So I get 10, 20, 20, 31, plus 9 is 40. Okay? And this is n, right? So now what did I just do? Here's my numerator. Here's my denominator. So it's going to be 40 divided by 30. And so what does the average turn out to be? 1.3. If I use my rounding rules, okay? So my average is 1.3, okay? Now, notice that if I did this formula, which means I took out 0, 0, 0, 0, 0, so I wrote out all of these values, right? So I would have 0, 0, 0, 0, 0, 0, and then how many ones do I have? 15 ones. 1, 1, 1, so on and so forth. If I wrote out all of the values and used this formula, I get the same thing. Well, I know I don't want to do that. I know you wouldn't want to do that. So using this formula for finding an ungrouped frequency distribution, much faster. Okay? So just keep that in mind. So that's how you find the mean of an ungrouped frequency distribution. So for ungrouped frequency distributions, the mean will always be the same. Okay? It will be the real mean. Okay. So now let's talk about the other case. And that's for grouped frequencies. So for grouped frequency distributions, okay? So the example I'm going to use is the one that we did on page 49 regarding the heights of semi-professional soccer players, okay? So I'm going to use that example again since we're familiar with it. So let me do the table. Okay. So I'm going to use the, it doesn't matter if you use the class limits or the class boundaries. I'm going to use the class boundaries. So I'm going to use lower class boundary. Oops, let me do this. I need to rewrite this. Okay, I need 4 columns for this. So let me do it over here. Okay, so if you remember, we started with 59.95, and remember the class width was 2, okay? So this is going to be lower class boundary, upper class boundary, and frequency, okay? So I'm just going to quickly fill this in. Okay, and then the upper class boundaries, if you remember, were okay. This was 60, yeah. 61.95, and then 63.95, and then 65.95, and 67.95, 69.95, and 74.95. I'm just trying to make sure, keeping these matched up. And 75.95. Okay, so there's the boundaries. Okay, so if we go across here just to make sure things are lined up. Okay, now what's the middle for? Well, a couple of things. Well, we don't have the data. That's the main thing. In this case here, we don't know what the data is. All we have are the classes. So we don't know what the data values are that fall into those classes. So what do? Well, we have to make an assumption here. And so the assumption that we're going to make is, well, not the assumption, but what we're going to do is we're going to use the midpoint of each class for the value of x. Okay? And that's the best we can do. We can't really do anything else. So let me write down the frequencies for the table. So we have 5, 3, 15, 40, 17, 12, 7, and 1. Okay? So here are the frequencies. Now here's the thing, is I know 5 of the values falls between these two numbers, but I don't know what they are. Okay? Well, I'm going to end up using the midpoint. So that's what this here is going to be. So I'm going to determine the midpoint. Now there's two ways you can use this. So you can use m sub mp, x sub mp, so mp for midpoint. Okay? So here's going to be the midpoint. Once you have the first midpoint, then you just add the class width, which if you remember is 2. Okay? So what's the midpoint for the first one? Well, we saw that the midpoint for this first one was 54, excuse me, not 54. The midpoint between the two is going to be what? What are we going to do? Well, let's figure it out. So it's going to be, so xmp, let's do the first one. So it's going to be this plus this divided by 2. So it's going to be 59.95 plus 61.95 divided by 2. And so if we add these up, what do we get? We get 121.9. So we get 121.9 divided by 2, and what does that give us? Well, that gives us, let's see, 50, 60, 60.5, so that gives us 60.5, 60.95. Okay? Which should make sense, because remember, if we're halfway between 59.95 and 61.95, well, the difference between these two is 2. So we just count up 1. So if we count up 1 from here, it gives us 60.95. Makes sense. So this is our midpoint. So here it's 60.95, and we just add 2 all the way down. So 62.95, 64.95, 66.95, 68.95, 70.95, 72.95, and 74.95. So now, that's the midpoint. So what columns are we going to use to calculate our mean for this distribution? We're going to use this column and this column. And we're going to use the same formula, except we're going to use XMP, the midpoint, instead of the data value, okay? Because we don't know what the data values are. So to calculate the sample mean, X bar, it's going to be the sum of XMP times the frequency divided by the sum of the frequencies, or the sample size, okay? Okay, so again, we can get this from just summing this column. So again, there's our sum of F. And so the sum of F, if you remember, is 100. Okay, so the sample size, remember the sample size for these semi-professional soccer players was 100. Okay, so we know that this is going to equal 100. Okay, which it does. Okay, now we just need to figure out what this is. Well, so if we extend the column, right? So this is going to be X sub MP times the frequency. So we're going to take this column times this column. So we're going to take 60.95 times 5 and put that number there. Then we're going to do 62.95 times 3 and put that number there, and so on and so forth. So let's do that. Okay? So let me take a minute. And okay, so